Hey, fellow mathers, before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians, welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, where you're waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor students to think and reason like mathematicians did when they were young students. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
Hello, how you doing?
How am I doing? I'm doing pretty well. Pretty well. We have lots going on right now. Would you agree with that?
Yes.
Lots of things. Lot happening, but we're having fun. We're having fun with it, and we are excited about the work that we're doing. We love the work we do. Yeah,
we do.
How are you?
It's funny that you say that. I'm good. It's funny you say that because I found a review for us.
Oh,
and
nice.
It kind of actually mentions some of the work we do. So I'm going to dive in because it's a little bit long.
Okay. All right. Go.
So Beach Bum 2010. I like it. Says, I simply cannot find the words to describe how I have changed as a mathematician since beginning to follow Pam and her work. Mm-hmm. I am about to begin year 33 as a K-6 educator.
Woo! Clap.
Over the past 3 years, I have listened to every podcast, some several times. I've participated in every challenge, I think. I have immersed myself in the DMR twice and have done 2 other deep dive workshops. I am currently working on funding to become a journey leader so that I can help my colleagues know better so they can do better. Love that.
Aww.
Doing math with the confidence I now have is so much fun as well as addictive. Do yourself a favor and join the Math is Figureoutable movement. You will not be sorry. Look at that endorsement.
Wow, that is wonderful. Thank you so much, Beach Bum 2010.
Yeah, I want to know who you are. Send me an email.
Yeah, tell Kim who you are. Oh, that's awesome. Some wonderful things that you can join in. We run challenges at least 3 times a year. We have the Developing Mathematical Reasoning Workshop. That's the DMR. It's still free out there that you can take. We have deep dive content workshops and then our journey program. Kim, we're having a lot of fun.
Oh, that's my favorite.
That is, yeah. And you do an excellent job in there. And we do some really, really cool things in Journey. And then we have leader support in our Journey Leader program. So if you're a coach, a leader, anybody out there who leads mathematics teaching in any way, check out our Journey Leader program. And we're so glad, Beach Bum 2010, that you're in there. Love it. Or that you're getting in there. Yeah. Let's make it work.
Okay,
cool.
Let's dive in. We have lots to say. I feel like our episode last week was a little long, but
it was a little long.
It's fine. Yeah. If they hate it, they can turn it off. We'll just keep talking. Okay. So last week we did chat kind of big picture, major things to know, major things to consider when working with integers kind of in general. So today let's dive in and get specific to the work of operations with integers, which I think a lot of people will love. So let's chat about integer addition today.
Yeah, integers, negative, positive numbers. Let's really think about how we can operate. I told a little bit in the last episode about how I was working with it was kind of a random group of kids that I grabbed, and I was just like, hey, based on the work that you've done with whole numbers, just kind of tell me how you're thinking about it. And because they had already just been reasoning about whole number addition and subtraction, they just continued to reason about integer addition and subtraction. And I thought it was fantastic. I've done a lot of work since then to make sure that it works for all kids and that it makes sense, mathematically and everything. That was just kind of my early, let's experiment. I've done that a lot, Kim. A lot of the work that we have put out in the Math is Figureoutable movement is stuff that I bumped into, ran into, tried anecdotally, and then did let me make sure that mathematically this is true, and, did all the reading and everything to make sure that it would fit, and then continue to experiment. Let's do that today. I'm going to actually do kind of a string that I did and do with people to get at integer addition. So, Kim, do you have any idea the elevation that we are at here? We're south of Austin.
No, I have no idea.
So
it's 4 hours to the beach. But I don't know. I don't know how
when you
climb to get.
Okay, when you run cap to coast. So cap to coast is Austin to the coast, the Gulf Coast.
No idea.
Well, let's ask you, when you run it, do you run uphill or downhill? Is it flat? Is it totally flat the whole time?
No. And you probably shouldn't ask me because I tend to like the hilly ones. I think there's some uphill and downhill. So overall, I would assume it's downhill, but
because
we're heading towards the beach.
Because you're heading. Well, you're just assuming.
I mean, I am, but I don't know. Are we?
Well, we are 425 feet above sea level.
Yeah, I don't feel like it's
Austin. Yeah,
I feel like we're pretty flat. No mountains here. Sorry.
So when you run a little downhill, but it's not like big downhills and stuff.
No.
Yeah. Okay. I know that our scouts, when my kids were in scouts, they did a canoe trip from here to the coast, and so the water runs that way. So that's got to be downhill a little bit, right? If the water runs that direction. Okay, there's the geography for Pam today.
Geography's not my thing.
Okay, so elevation. If we're talking about above and below sea level, could we picture ourselves on the coast? There's these hills. There's sand dunes. Maybe there's like the hill by the like there's some above and below the kind of ocean level here. So we're on the beach. And Kim, you decide to walk up the sand dune, and it is a 25-foot tall sand dune. So that's where you're starting. You're 25 feet above sea level. And then you saw a higher sand dune, and you're like, ooh, that's 34 more feet. So you started at 25 feet. You walked up 34 feet. Where are you?
I'm at 59 feet.
Above sea level. Okay, cool. And I could represent that on a number line. And if I've drawn a number line on my paper, I'm actually going to throw 0 kind of in the middle of my number line here. And then I'm going to go over to 25 to the right, and I'm going to make a jump of 34. And you said when you did that, you're at 59. I could have done a vertical number line. I don't know why, but I chose horizontal. I think you can do either. I think
you should do both.
It's good to have both. Absolutely. Yep. Good to have both. Okay. First problem, 25 plus 34 is 59. You don't have to think about that very hard on purpose. Next problem, you swam down and you're in this underwater sea cave that is 25 feet below the sea level. And in that sea cave, you can go up and down and everything. And you walked down, and you've now walked down. That says, hey, if you want to take this trail, it's going to go 34 feet further down. So you are adding a walk of 34 feet down. So I've now written on my paper minus 25, negative 25 plus negative 34. What do you got?
I am at negative 59
How do you know?
feet. I drew a vertical number line and I put negative 25, but then I went ahead and put 0 also just to kind of like orient my head. And I just was at negative 25 and I jumped down negative 34 and that was negative 59.
Yeah, nice. Let me tell you what my board would look like if I was doing this problem string. So I have that first number line where I have 0 kind of in the middle, where we did 25 plus 34. Where you started 25 and then you walked up 34 more. And so that is the 0's in the middle. And then I have start at 25 on the right, to the right of it, jump 34 and end on 59. So I kind of have this jump of 34 over on the right from 25 to 59. But then the second number line for the second problem, which was negative 25, starting at negative 25 and then walking down another 34. I have a number line underneath it, but the 0's are lined up.
Yeah.
So the 0's are lined up where you can see, they're lined up. And then I went the same distance back that I went forward 25. So the 25s are the same distance away from 0, but the negative 25 is to the left of 0, where the positive 25 is to the right. And then I'm jumping 34 back, kind of like you jumped down. I'm jumping 34 back and I'm landing at negative 59. So if you were to see my paper right now, I actually kind of have the same thing on two sides of the zero.
Mhm.
I have the same jump of 34. One's going to the right because we were adding 34, and one's going to the left because we were going further down in the cave 34. One's landing on positive 59, one's landing on negative 59. So they're I wish you could see my paper, but it's one that jump is to the right and the other one is to the left. And
Mhm.
zero is kind of that constant kind of in the middle. Next problem. How about if you started in that sea cave, you're down negative 25 feet, but this time you walked up in that sea cave and you walked up 34 feet. Where are you? Are you still below? Because you started negative 25. Are you still below? Are you above the water? Are you like, where are you as far as the water level goes, sea level?
So I just went back to the number line that I had just done, and I
Mhm.
went back to the negative 25. And I know I was going up 34. So I went up 25 to get back to the zero that I had. So I moved up 25. I'm at zero. I haven't gone all 34 yet. So then I knew that I had 9 more to go. And so then I went up a jump of 9 to land on 9.
Because from zero, a jump of 9 would land you on 9.
Mm-hmm.
Cool. So if you started 25 feet below and you walked up 34 feet, you're telling me you're now above the sea level by 9 feet, or 9 feet above sea level. Yes?
Mm-hmm.
Cool. So on my paper, and what my board would look like if I was doing this with students is, again, I have these zeros lined up. So on that first problem, I kind of have this jump of 34 on the right. On the second problem, I have this jump of 34 back on the left. But on the third problem, this one we just did, like you, I started at the same negative 25. So the negative 25s are lined up. But this time, I'm kind of doing the jump of 34 to the right over zero, kind of like you
Mm-hmm.
said. So
Mm-hmm.
up 25 and then up 9 more and landing on the 9. Okay, cool. Next problem. How about if I said, hey, you're above sea level, you're on that sand dune, the 25 feet above sea level, and you don't really dive off a sand dune. You're not on a sand dune. You're on a cliff above the sea level. And this is cliff diving. And you
Mm-hmm.
decide that you are going to dive. And how did we measure this? This might not have been my best context ever, because you are going to dive 34 feet. And I'm kind of curious. Where are you if you dive 34 feet? Are you above the sea level still? Like, are we catching you mid dive and you haven't hit the water yet? Like, where are you?
I'm in the water. So when I jumped 25 down, then I was at zero, but I hadn't completed the
Because
34
you
feet.
because you started at 25, right?
Yeah.
Start at 25,
Yeah.
jump 25 down, you're at zero. Okay.
And then I still had 9 more to go. So one more jump of negative 9 is at negative 9.
So on my paper, I've got those number lines where all these zeros are lined up. And the positive, there's a positive 25 on that first problem. And so this last problem, two places where you started 25 feet above sea level, those 25s are lined up. And this time I drew that back 25 to zero. And like you said, another 9 is back at negative 9. So this one kind of looks different than all the other ones, except it also has a jump of 34. It also has a jump of 25 and 9. Whereas the problem
Mm-hmm.
before it had a jump forward of 25 and 9. This one had a jump backwards of 25 and backwards 9. Interesting that we kind of have the same numbers that are kind of all falling through here. One more thing I'll say is that then I also have the equation for this problem where I wrote 25. You started at 25. And then I wrote plus negative 34, because I kind of said something about how then you decided to dive. So decided was like this positive thing, and then dive was like negative 34. I could have written minus 34. You can have a conversation about whether you mean that you're removing 24, falling down, diving, or whether you decide to dive. That could be like add negative. It's a little bit of word play there, but you can get kind of either equation out of that. So I've got 25 plus negative 34 equals, and you said you'd land 9 feet below sea level. So negative 9. Okay.
Yeah.
So let me just kind of review a little bit how this problem string was a little different than the one we did last week. So the one we did in last episode was a lot of context all at once with a lot of different numbers, positive, negatives, all kind of floating around. And we're just really trying to get what the difference between positive and negative numbers and what's happening. In this one, I'm much more interested to in what the equations are looking like. I'm still staying in context. We're still really reasoning about what's happening, but I'm kind of focused a little bit more on what the equations look like and how they compare to the number lines and how the number lines compare to each other. So we're really kind of looking at what's the same and what's different. So at the end of this string, which y'all can't see because it's a podcast, if I was with students and we'd be looking at the board, we'd be looking for, where are the 25 showing up? Where are the 34 showing up? And why? Like, what's happening? Why do we keep seeing 9? Why do we keep seeing 34? Why do we see 59 and negative 59? What's happening here? So, Kim, maybe I'll ask you a couple of those questions. Why do we see 59 and negative 59?
Because when you're adding the positive 25 and 34, then you have the positive 59. And when you're adding the negative 25 and the negative 34, then you have the negative 59.
Totally makes sense. Yeah.
Yep.
Why did we see 9 show up? Like for one problem, the answer was 9. For the other problem, the answer was negative 9. Like, why 9?
Well, because the distance between 25 and 34 is 9.
Oh, sure enough.
So it depends on if one of the numbers is negative. Like when you had negative 25 and you increased 34, then that gave you 9.
Because you're kind of looking at the difference between those two.
Yeah.
So notice in this problem string, we kept the numbers very consistent so that kids didn't really have to mess around with addition and subtraction. Once they had figured the 59, they could just use that in the next problem. Once they'd found the difference of 9, they could just use that in the next problem. So we're not getting kind of hung up in diving into the relationships between the numbers. We're like, all right, we got the relationships. Well, what's happening here? Where are we? Are we negative? Are we positive? Are we looking at what's in between them or not? Are we adding them together? And so we can really kind of focus there. So that's just a different kind of structure of a problem string. So we kind of relieve some of the cognitive load a little bit so we can focus on the part that we wanted to.
Right.
I would suggest you can do strings just like this with temperature. Sort of stay in temperature and have the storm comes, the temperature drops. There's a heat wave. You walked into a sauna and the temperature rose. You started in where's the place where you'd start that's really cold? You started outside and Alaska. You started outside in Alaska and you walked into the house. Like there's ways that you can kind of sort of play with temperature and different contexts. Also use debt, especially when you're with addition. You can add a debt. That makes sense. I can add a debt. So how much money do I have now? I start in debt and I earn money. I start in debt. I add more debt. It's a fine thing to do. And then again, you can use American football, but always, always, always from the line of scrimmage, not from the 0 line on the football field. Cool. All right.
Actually, we talked a little bit, or we at least mentioned the teacher Facebook group last week, and I decided to go in there and see what questions had come up. And I answered them at the time, but I'm curious if you give your answer to a couple of the questions. I just
because integers been a hot topic. People have been asking questions. Absolutely. All right, what do you
got? So one of them was about the minus or subtract symbol versus the negative sign.
Yeah. That's interesting. So it's a notation thing, but it's also really connected to meaning, and it's tricky. I don't know, teachers, if you remember the first time that you looked at a problem that had a subtraction sign and a negative sign in it, and you're like, are those the same thing? Like, what does it mean? Are we subtracting 25? Or does adding a negative 25, is that equivalent to subtracting 25? Does the negative sign, is it little and it kind of goes up? You know how you see sometimes typesetting where I'll write negative 34 with a little tiny negative in front of the 34, but sometimes we write it as the same symbol as the subtraction minus sign. So that can be super confusing. So what I usually do with students is do what we've just done in last episode and this episode, where we are in context and I'm representing as they're thinking about it. And I will be incredibly inconsistent. Now, somebody just was like, no. In other words, sometimes I will write the negative 34 as a little tiny negative by the 34. And sometimes I will write it as a big minus in front of the 34. And sometimes I'll put parentheses around negative 34. So I might have written I didn't today, interesting, but sometimes I will. I'll write 25 plus parentheses negative 34 in the parenthesis so that
Mhm.
you can kind of really tell that it's negative 34 and I'm not writing plus minus, I'm writing plus negative 34. I think often that's when we put the negative up high and kind of small is when there's an operation in front of it. So if it's like
Mhm.
plus negative 34, then we'll write the addition symbol and then we'll write that tiny little negative. But
Mhm.
sometimes we don't. Sometimes we'll write plus minus 30, the subtraction symbol 34. So I will, as students are reasoning about context, and we're not trying to get them good at operations, but we're really reasoning about the meaning of integers, I'll be super inconsistent so that kids kind of get used to lots of different notation.
Mhm.
Then, as we start to get into operations, then I'll say, "Wait a minute, is this negative? Does this symbol right here? Does that mean minus? Does that mean plus?" And we start to reason that it can mean both,
Yeah.
and it depends on what you're thinking about, and we can bring both meanings to bear sometimes, especially when we're doing subtraction. We can that it can mean both. So I might have something like 25 minus 34, and I could say, is that 25 subtract 34? Is that 25 plus a negative 34? And how can we make sense of both of those? And that's actually a good place to be, where we want students to sort of realize that we can think about subtraction as adding the negative number.
Mhm.
25 minus 34, we can think about as 24 plus negative 34. But so that's complicated. Part of it is notation, where we just have to tell
Yeah.
kids this is what we do. Part of it is let's actually work through kind of the meanings of both of those.
Yeah, and the more we have kids wrestle with the meanings and think about things in context, then it doesn't just look like a symbol and they're not really sure what to do with it. Here's how you know that you didn't look at my questions ahead of time. The next question I was going to ask you was, do you ever put parentheses around
Oh, look at that.
negative numbers?
I
Do you
answers
have
your
anything
little
you want to add to that? You kind of
um
mentioned it.
so here's what I'll add is I'm sure there are some middle school teachers right now that are a little bit like steam is coming out of your head, or what's that picture where you're like, wait, Pam, what? Because you're clear. Let me just give you the homage to say I am with you that this is complicated for kids. And I'm going to guess that some of you out there right now are like, no, 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 Pam, we have to be super consistent or kids get really confused
Hmm.
and mixed up. To which I'm going to say, they're going to reach this inconsistency. It's
Yeah. What about next year?
even if you don't do it, it's going to show up because we as a culture are not consistent. And because there is this ambiguity about, are we subtracting or are we adding a negative?
Hmm. Hmm.
And that because that ambiguity exists, I would rather face it up front,
Hmm.
make sense of it, give students the space to grapple with it while I'm there as that helpful other, more knowledgeable other, where I can see, this is right on the edge of your zone of proximal development. Let me kind of scaffold help for you to grapple here. So we really want kids to grapple. I know it is so much easier to just tell kids plus plus minus minus or minus
Hmm.
minus plus plus, like I just said the rule backwards. Like it is so much easier to just give kids a rule. They do it. They're getting answers. Whoo! They're less stressed. The anxiety level goes down. Uh, but
On
but
the day that you tell them that, and then what about 5
well,
days
to be
later?
clear, as that stress goes down and sort of the grappling goes down, the thinking goes down, the
Mhm.
reasoning goes down. So it's not about having guess what's in your kids guess what's in your head. It's not about having them like figured out on their own. It's about giving them the space to grapple in contexts where you're helping them make sense of it, where you are there to help scaffold and not let it get to where it's unproductive struggle. And super, super important. I hear you clearly, middle school teachers, where you're like, that will take so much longer. So much. Notice we just built in a lot of stuff that most textbooks don't do. Most textbooks have maybe a section where they're like negative, positive numbers, done, bam, and then we move on. I'm really suggesting that you spend some time getting kids really to ground themselves in what negative and positive numbers mean. You do that using problem strings like we did in this episode, in the episode before. And in that space, they are now, they're making sense of it. I know that's harder. I know that takes longer. But the alternative is what we then see, which is mixed up, messed up, kids memorizing, kids mimicking, and they're not doing real math. So
Mm-hmm.
do I want to get kids to where they can just look at integer operations and just sort of be fluent? Absolutely. But I want fluency with understanding, not because they are just mimicking rules and then mimicking them incorrectly. Because let's be clear, that's going to happen all too often.
Mm-hmm. Do we have time for one more question? I don't even know
Yeah,
where we're
except
at.
let me just say one more quick thing.
Okay.
Because you might be like, no, Pam, but I got kids that get it. They get the rules, they move on. So did I. I was the student that got the rule fast, applied it correctly every time, and I was robbed from real math. So don't rob the me's of the world either from really reasoning about what's happening. I don't know. You tell me the question? I'll see how deep
Oh,
it is.
well, it's maybe a topic. What are your thoughts on integer chips?
Oh
Maybe,
dear.
maybe we do it next week.
Yeah, I think we better put that one off.
Okay.
Let's do
All
that one
right.
next
Sorry,
week.
listeners. Listen next week.
Well, hey, listen next week and we'll talk about integer chips. What are the pros and cons and when to and not to? All right, cool. Bam. Thank you. All right. Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Hey, and chances are high, we'll also start integer subtraction next week. All right. Bye, y'all. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.